Today we will talk about Iceberg and Spark integration. Iceberg is very popular nowadays with compute engine. Compute engine in the sense processing data. So there are multiple integrations available of Iceberg with various compute engine like Spark, Trino, Flink, Athena. But today we will focus on Iceberg and Spark integration only. So what is an Iceberg? Iceberg is an open standard table format for analytic dataset or for OLAP data processing. It's used for managing metadata, schema, and the transactions. As you can see, we have four layer compute engine, table format, and file storage. Iceberg is a middle layer, table format and file format layer between compute engine and the file storage. Compute engine focus on data processing like transform transforming a data extraction, and for the storage, when the compute engine want to store data on file storage, it will go through the iceberg. The iceberg will provide schema and the data organization, and the final data will store on a somewhere disk or on a cloud storage. So it's a kind of a middleware. Compute engine not concerned about schema management, the transactions, and metadata of table. We can map these four layer with actual tech stack. For example, in this diagram, the compute engine we can map with Apache Spark, Trino, Flink, and AWS Athena, which are data processing engine. The next layer is table format that we can replace with Iceberg Open Table. Third is file format where we will organize the data. We can use Parquet file format, which is very optimized for columnar data processing. And the last layer is file storage, where we have AWS, cloud storage, GCP, Azure, or you can store on local disk also. Now, what are the advantages of Iceberg? So, Iceberg will provide you schema evolution, time travel, asset transaction support, and partitioning. Schema evolution meaning you can run DDL, DCL, and DML commands, very similar to SQL. Time travel, with the help of time travel feature, you can go back to the history of your transaction. For example, in a first batch, you have inserted 10 rows, and after some time, you have inserted another 10 rows. So now we have a 20. But if you want to go back and check the first 10 rows or old 10 rows or previous version of 10 rows, you can go and check back in history. So there are some commands available that you can use and see what kind of data inserted in the past or how many rows inserted in the past. So it's very useful feature when you want to do some audit or analysis or rollback. Asset transaction is very important property of RDBMS through which we can manage atomicity, consistency, isolation, durability of data. Partitioning partitioning is kind of a sharding. With the help of that, we can organize data in a Parquet files. So it's very useful while we are fetching the data and writing the data. Now, as a developer, we will have to focus on table only. We are not checking or managing the backend stuff. That will be managed by Iceberg process or framework. So as a developer, we will have to create this simple table. So if you see, this table is 80% similar to SQL, the standard SQL creation process. So we have a department tables where we have three columns or properties: department ID, department name, last updated timestamp. Very normal data type similar to SQL. The change is here using Iceberg and partition by. Using Iceberg will tell you this table is type of Iceberg, and this will be managed by Iceberg framework. And the partition by, which will organize your data at the backend or create a Parquet file accordingly. Jump on demo part. So today we will give demo using Apache Spark 3.5. First we will need to create a local folder iceberg underscore spark, and then inside it download Spark runtime environment 3.5.3, extract it and make all these configuration from step number 3 to 8 on your local environment. Then you have to download this Iceberg Spark runtime environment, which will manage Iceberg stuff. And third, you will need to create a one local folder inside iceberg underscore spark to manage data files. So I already have this Spark runtime environment, Iceberg Spark runtime environment, and warehouse folder. So you can see it's empty as of now. So now next step is to launch Spark Shell CLI. So in Spark Shell CLI, we will have to pass a couple of important parameters like packages, where we will pass Spark Iceberg and Spark runtime environment jar path. Uh, we have to tell this is a local, uh, the files will be getting created on local disk, and we will have to specify the warehouse path, and the catalog will be local. So this kind of configuration we will need to pass. So let's launch Spark Shell CLI. Okay, it's getting started. Okay, now you can see the CLI is up and the Spark version is 3.5.3. Okay, so let's do some basic sanity first. So we have two catalogs, local and the Spark underscore catalog. Spark underscore catalog we are not going to use for some reason. We will be using local catalog. Let's check database. It's empty as of now. Okay, we'll create schema first. So database will be created automatically, which will create schema like this. Local is a catalog, db, database will be db, and your actual table name. Okay, it's get created. So you can see this, we are using iceberg table type and partition by department ID. It's empty as of now. Let's insert a couple of records. Okay, you can see there are three records we have inserted. Same way we can create another table, which is employee table, and partition by employee ID, and we will insert some of the records here, and you will see the data. Okay. Now, if we go to the backend, we have created warehouse folder. So let's see how things are. So you can see the DB folders or database folders created, and inside this there are two folders. One is a department and the employee for the table which we have created. And if we go inside one of them, what is structure, the data and the metadata. And inside data, you can see there are three folders created. One is a department ID 1, department 2, and 3. This is because of partitioning ID. Our partitioning ID is department ID. So based on that, the data is organized into three folder. And if you go inside any of them, you can see there is a Parquet file. So same way the same structure will be in employee folder. Like this way, right? Now you can see why we are using partitioning ID, because it will create a folder structure and Parquet file accordingly. So it's organizing a data or sharded the data into multiple files. So this is schema creation. Now we can explore second part, schema evolution. This is also schema evolution. It's like a next phase where you can modify or you can change data type. Suppose I want to change this, update some of the information. Sorry, not here. Okay, yeah, because we have not done this alter command. Okay, we have added a new column, bonus column. Then we are setting up the bonus value using this query, right? Or we are inserting some of the we are inserting one more record into the employee table like this way, and one record we are inserting into department table. Now if you see the employee, the department first we can see. So department we have 4 rows. Same way we can check employee also. Now you can see there are one extra row and also bonus column we have added. So now you can see we can easily run the SQL alter commands or schema evolution commands. Now how about the time travel? In a time travel, basically we can go back and check the history. So you can see we have done schema creation, data insertion, then altering of it, adding a column, and we have added extra data also. So if I see, if I go back and check the history, for example, we can check history of department table from last, we can say 3 minute. For the 3 minute, if we go and see, we have three records initially we have, right? But if I go for the last 1 minute, we can see we have four records. So now you can see we have inserted one more department which is fourth one, services, right? So this way we can go back into the history and see the difference of data, and you can revert, you can roll back, or you can see what are the changes and what are things going on inside your table. Okay, this is another way you can go through this. You can check with the snapshot id. So for the snapshot id, you will need to first get snapshot id. So this will give you the snapshot information, and from here you can see the snapshot id, and also you can see some of the details, uh, how many records has been added in first snapshot, how many record has been added in a sec, uh, second snapshot. Okay, so if you want to check through snapshot id, then this is one of the command which we can use. We can just replace the snapshot id, like the snapshot id, um, we can pick, and here, so it will give you these are the records has been added or modified or managed by this snapshot, right? You can execute complex query also. Mean you can joins your data, and you can perform some kind of OLAP or complex queries like this way, where you need some combining both the table, or you can run some aggregation queries also on both the table, like this way, where you want to average, max, count, this kind of things you can do. Coming to the asset part, so asset basically, so when we talk about the assets, it's about atomicity, consistency, isolation, durability. So when we run the multiple transactions, so the iceberg will ensure your data should be consistent whenever you do any kind of CRUD operation. So I think that part we have already done, and it's a just a demo, because we are just executing query one by one, so we don't have so much load. So we can run on a simple query like updating existing data or certain new data. So you can see it's running perfectly without any issue. So we can run any DML kind of query without any issue. Okay, so I think we have covered most of the things as part of this small demo. Thank you.